Good afternoon, everyone. Today I'm going to talk about SCM Life Sciences, platform technologies, and preclinical and clinical outcomes with the clonal mesenchymal stem cell product. Today I want you to pay attention to the word clonal. I'm going to explain what that means in a few minutes. And let me start with a brief introduction of SCM Life Science. And the name SCM comes from the name of our core technology called subfractionation culturing method. It has another broad meaning, stem cell medicine. And we have been developing allogeneic clonal mesenchymal stem cell product. Our platform technologies include isolation of clonal mesenchymal stem cells and manufacturing process of clonal mesenchymal stem cell product. And currently, we are focusing on developing a product to target immune diseases. And we just started phase 2 clinical trial for the treatment of GVHD. In terms of facility, we have our own GMP facility. As you know, mesenchymal stem cells can be isolated from several different tissues. And these stem cells have immune modulation property and multipotent differentiation. These are the reasons why these stem cells can be developed as stem cell therapeutics and used in tissue repair. I think there are three main hurdles to overcome in this MSC field. First, we need to improve efficacy. Second, we need to develop disease-specific treatment. Third, we need to reduce the treatment cost. And people are talking about these strategies on the left-hand side to improve the efficacy of MSC treatment. These include using differentiated MSCs and using gene-inserted MSCs and using other types of stem cells, such as iPSCs. The strategy we took was using clonal MSCs. Clonal MSC means MSCs from single cell or single colony of cells. And this way, we produce highly homogeneous population of MSCs. And we have proved so far these clonal MSC produce higher efficacies in 5 different animal models. And before I explain the isolation method, I'm going to just briefly point out we are isolating these mesenchymal stem cells among other types of cells. For example, in bone marrow, in addition to MSCs shown in green, there are other types of cells, such as fibroblast, osteoblast, adipocyte, etc. And this slide shows the conventional isolation method called density gradient centrifugation method. And I'm going to call this method GCM in short. And briefly, if we load bone marrow or adipose tissue samples onto gradient solution, after centrifugation, you can get a layer of mononuclear cells. You take these mononuclear cells and plate onto culture dishes. And there are 2 types of cells. One is floating around cells, and the other one is adherent cells. So within 1 to 3 days, you get rid of all these floating around cells and keep expanding adherent cells only. And people use this kind of cell stack system for large expansion or bioreactor systems. In 2006, International Society for Cellular Therapy published a paper saying MSCs using this isolation method and culture method heterogeneous population of cells. So they said these cells should be called stromal cells, not stem cells. So in order to overcome this heterogeneity problem, we have designed this new isolation method called subfractionation culturing method, SCM in short. And briefly again, we usually mix 1 ml of bone marrow sample with 14 ml of culture medium and plate them onto culture plate and transferring supernatant only to the next clean dishes with certain time intervals, like 2 hour, 2 hour, 2 hour, 1 day, and 2 days. And the hypothesis here we had was this low dense mesenchymal stem cells still can still be in the supernatant. They can be transferred to the next dishes. So if you can see, after serial transferring, you can get well-separated colonies. So we pick these well-separated colonies and test. The cells in these individual colonies have mesenchymal stem cell characters. So after we characterize these cells, if they have mesenchymal stem cell characters, these cells move to clonal MSC library. And this slide shows the overall manufacturing process of clonal mesenchymal stem cell product. As I showed, we start with colony isolation, then establish master cell bank cells, working cell bank cells, and final product. We have two types of final product, fresh and frozen. This slide shows the real pictures of fresh and frozen stem cell product. And again, our final product contains highly homogeneous MSCs compared to conventional MSC product. And so far, we have tested numerous clonal MSC lines, and this is what we found. On the left, on the panel 2 shows the T-cell suppression activities of those 9 clonal MSC lines. And among these 9 clonal MSC lines, we found only 5 lines shows great T-cell suppression activity. And this means we can pick cells, clonal MSC line showing great T-cell suppression activity. So this this also suggests that MSCs using conventional isolation method is the mixture of cells containing this good and bad T-cell suppression activity. And this slide shows the 3 distinguished features of our clonal MSC product. As I said, we use MSCs clonally expanded, and we select subpopulation of MSCs and characterize them. We use this characterized subpopulation of MSCs. Recently, we added another strategy to increase the efficacy of MSC product. That's a mechanism-based approach. What that means is the following. And in inflammatory condition, immune cells are activated. These activated immune cells secreted neurotrophic factors such as NGF and BDNF. These neurotrophic factors stimulate MSCs, and then these MSCs get conformation change. Then these conformation changes MSCs produce acetylcholine. This acetylcholine binds to activated immune cells. We found there's elevated expressed acetylcholine receptors on immune cells. This is the way these MSCs suppress immune cells. Another mechanism of action we found is we found how these MSCs induce regulatory T cells. We found ICOS ligand expression is induced on MSCs. And we also found its counterpart, ICOS expression, is also overexpressed on regulatory T cells in inflammatory condition. So this increase of this interaction between these two cells leads to IL-10 secretion induction, and then this will result in immunosuppression. And also, we also found out when we tested conventional MSCs and 5 different clonal MSC lines, what we found is one of the one of the lines, HC-MSC4, express highest level of icosahexaene. This means we can select this line to treat immune diseases. Again, and we are mechanism-based approach means we are adding another level of increasing efficacy of MSC product. And so far, we have published more than 35 papers and international patents on isolation of clonal MSCs and manufacturing process and disease treatment patterns. Our first indication is GVHD. So we tested efficacy of this clonal MSC product in GVHD animal model. While we tested this efficacy, we also compared our clonal MSC product to conventional MSCs. As you can see on the left-hand side, the two clonal MSC product shows higher survival rate compared to conventional MSC product. And this slide shows how much clonal MSC product shows efficacy to this steroid refractory GVHD patient. And the first patient on left-hand side got a very severe GI tract GVHD. After a couple of infusions of clonal MSC product, as you can see, this picture shows the before treatment. This is 10 days, 1 month, and 3 months after a couple of infusions. And the second patient had a very severe liver GVHD, and his total bilirubin level was 14.6 at the first infusion. And he's got also a couple of infusions. After a couple of infusions, his bilirubin level went back to normal. So these two patients got out of a hospital 4 weeks and 3 weeks after second injection. And this slide shows the summary of our phase 1 clinical trial. We did phase 1 clinical trial with 9 chronic and 1 acute GVHD patient. We monitored safety for 5 weeks, and the conclusion is the following. We found only 1 patient showing mild muscle weakness, which is gone in a few days, and there's no other adverse event. And we also checked efficacy of this single injection, and we observed this much of efficacy in these organs. We just started phase 2 clinical trial for the treatment of steroid refractory chronic GVHD patient. And injection route is IV, and we use 1 million cells per kg, 3 injections with 2 weeks intervals. And the total number of subjects is 72 patients, and we are doing this clinical trial at 6 top hospitals in Korea. I think I can compare these clinical trials because Mesoblast published these clinical outcomes. And compared to the Mesoblast, in Mesoblast clinical trial for the treatment of acute GVHD patient, they used 2 million cells per kg. They infused 8 times, twice a week for 4 weeks. And we are planning to inject 1 million cells per kg and 4 times. And this slide shows the pipeline of SCM Life Science. And after chronic and acute GVHD clinical trials, we are planning to do clinical trials for the treatment of acute pancreatitis, liver cirrhosis, atopic dermatitis, and type 1 diabetes. This is my last slide. I told you there are three main hurdles in this field, and without strong platform technologies and strategies, we believe we can provide solutions to go over these hurdles. Thank you.